Welcome to the next installment in my video lecture series for managerial economics, and we're going to be taking a look at the Q&As in Chapter 9, and of course we're going to start off with Q&A 9.1. And that one says, given the general linear inverse demand curve, quantity is equal to A minus BQ, where A and B are positive constants. Use calculus to show that the marginal revenue curve is twice as steeply sloped as the inverse demand curve. So here we have our demand function, and in order to find the slope of that, we take the first derivative, and that gives us negative b. So in order to find marginal revenue, we have to find total revenue first, and total revenue is P times Q. So we already have what P is equal to, so we can just take this function here, the demand function, and multiply by Q, and multiply Q through that, and we get total revenue is AQ minus BQ squared. If we take the first derivative of that, we get marginal revenue, and that gives us A minus 2BQ, and you can see that the slope of the marginal revenue curve is negative 2b, while the slope of the demand curve is negative b, so the marginal revenue curve is twice as steeply sloped as the demand curve. Moving on to Q&A 9.2. When the iPad was introduced, Apple's constant marginal cost of producing this iPad was about $220. We estimate that Apple's inverse demand function for the iPad was P equals 770 minus 11Q, where Q is the millions of iPads purchased. What was Apple's marginal revenue function? What were its profit maximizing price and quantity? And given that the learner index for the iPad was P minus MC divided by P equals 0.56, what was the elasticity of demand at the profit maximizing level? So initially what we're going to have to take a look at, we have to calculate the marginal revenue function, then we're going to find out the profit maximizing price and quantity, and then we're going to find out the elasticity of demand using the learner index. So we have here marginal cost is 220, the inverse demand function is 770 minus, P equals 770 minus 11Q, and we're going to have to find out what marginal revenue is. So in order to find out what marginal revenue is, what it is, we have to find out what total revenue is. So we have P times Q. We already have P here, so if we multiply this, the inverse demand function, by Q, that will give us total revenue. So we multiply that through. We end up with 770Q minus 11Q squared. And if we take the first derivative of this function, we end up with 770 minus 22Q. That gives us our marginal revenue function, and that's the first part of this, the answer to this Q&A. So now we have marginal revenue, we have marginal cost and the inverse demand function, and we know that the profit maximizing condition is marginal cost is equal to marginal revenue. So if we set marginal cost and marginal revenue equal to one another, and then we solve for Q, that will give us the profit maximizing quantity. So marginal cost, 220, is equal to marginal revenue, 770 minus 22Q. All right. We simplify that, we end up with 22Q is equal to 550, because we're subtracting 220 from both sides and multiplying 22Q, adding 22Q to both sides. And if we divide through by 22, we get Q is equal to 25, and that, as the text said and as the wording of the question said, Q was in millions. So we have Q equals 25 million. So if we place that 25 million into the demand function, or the inverse demand function, we can find price. So we know that price is equal to 770 minus 11Q. We stick the 25 million into the Q there, and we end up with a price of 495. So this is the information about the learner index. It's P minus marginal cost over P is equal to negative 1 over the price elasticity of demand. And we were already given that this was equal to 0.56. So if we invert both sides, all right, so if we just have 1 divided by this and we flip this over, we get 179 is equal to negative the elasticity, and the elasticity is equal to negative 1.79. Moving on to QandA3, and with QandA3, a portion of this video is in a separate video. There's a portion of a graphical analysis that appears, and I just thought it would be better to do it in a separate video using this program that I have called Omnigraph Sketcher to help illustrate some of the changes in consumer, producer, and total surplus and the dead weight loss, etc. So in this particular video, all I'm going to be looking at is the determination of the profit maximizing prices and quantities for this, and then make sure you look at the other video to look at the analysis of the changes in consumer, producer, total surplus, and dead weight loss. So in this question, in the linear example in panel A of figure 9.3, how does charging the monopoly a specific tax of T equals $8 per unit affect the profit maximizing price and quantity and the well-being of consumers, the monopoly, and society? What is the tax incidence on consumers? So all we're going to be taking a look at is we're going to calculate the profit maximizing price and quantity before the tax and after the tax, and then the separate video that I've uploaded will take care of the remaining parts of this question. So just be aware of that. All right, so this was the inverse demand function that was originally given. Price is equal to 24 minus Q, and marginal cost was equal to 2Q. So in order to get marginal revenue, we need to get total revenue, and total revenue is P times Q. So we're going to have P here with the inverse demand function, so we just need to multiply this by Q. So we get 24 minus Q multiplied by Q, multiplying the Q all the way through. We get total revenue is 24Q minus 2Q, Q squared. And marginal revenue is just the first derivative of total revenue, and that gives us 24 minus 2Q. So now we have marginal revenue and marginal cost. We can equate these to one another. More marginal cost is equal to marginal revenue, so we have 2Q is equal to 24 minus 2Q. Adding 2Q to both sides gives us 4Q equals 24, and dividing by 4Q is equal to 6. Since we have Q is equal to 6, we can plug that into the inverse demand function. So we have 24 minus 6. So the price, the profit maximizing price, is equal to 18. So the profit maximizing quantity for this monopolist prior to the tax is 6. The profit maximizing price is equal to 18. Now there's an institution of an $8 per unit tax. This changes the marginal cost function to this. Marginal cost is now increasing by $8 because the tax is being placed on the monopolist. We have to take this into account, and this impacts marginal cost. So we have our original inverse demand function. We already know what marginal revenue is equal to. Marginal revenue is 24 minus 2Q. So if we set marginal cost and marginal revenue equal to one another and solve for Q, that'll give us the new profit maximizing output. So we have marginal cost is 28 plus 8 equals 24 minus 2Q. All right, so we have 2Q plus 8 equals 24 minus 2Q. All right, we add 2Q to both sides, and that gives us 4Q plus 8 is equal to 24. Subtracting 8 from both sides leaves us with 4Q is equal to 16. The new profit maximizing output level is equal to 4. We place that in the original inverse demand function. So we place 4 into here, so we have 24 minus 4. So the new profit maximizing price is equal to 20. If you go and look at the other video that I have posted specifically to this, it'll go through the remainder of that. I apologize for the discontinuity, but it just seemed that using this format to start the problem and then using Omnigraph Sketcher to illustrate the other part, to me it just provided a better way of explaining the other parts of this question. So again, I apologize for that discontinuity, but I think you'll understand when you see the video why I did a separate video using a different application for the remainder of this question. QandA 9.4. A firm that delivers Q units of water to households has a total cost of the cost as a function of Q is equal to MQ plus F. If any entrant would have the same cost function, does this market have a natural monopoly? So this any entrant's going to have this same exact cost function as the monopolist at the time. So here's the cost function, and we're going to denote that firm 1's output is denoted by Q1, and that firm 2's output is equal to Q2, and that the total output is just going to be the summation of those two individual firms. So each of these firms is going to have this cost function. All right, so we're going to have the cost of firm 1 and the cost of firm 2. They have the same cost function, so it's MQ plus F, but remember now they're splitting the output, or they're just adding Q1 and Q2 is going to give us the total output in the industry. So we have MQ1 plus F, and then we have to add in the cost of the other firm, which is MQ2 plus F. So rewriting that, we can factor out the M, so we have MQ1 plus Q2 plus 2F. We add the two F's together. And then since we know that Q1 and Q2 are equal to Q, we can place Q into there. And what we end up seeing is if an entrant enters this marketplace, originally when there was a monopolist, total cost was equal to MQ plus F. Now that there's an entrant, total cost is equal to MQ plus 2F. And this meets the definition of a natural monopoly. If the total cost of the industry increases with an entrant, it is considered a natural monopoly. And since the costs now are MQ plus 2F versus MQ plus F, this meets the definition of a natural monopoly. And the final QandA 9.5 from this chapter. A monopoly's inverse demand function is P equals 800 minus 4Q plus 0.2A to the 0.5 power, where Q is its quantity, P is its price, and A is the level of advertising. Its marginal cost of production is 2, and its cost of a unit of advertising is 1. What are the firm's profit maximizing price, quantity, and level of advertising? All right. So let's take a look at this. We know here's the inverse demand function. We want to know what total revenue is, so we have to multiply this by Q. So we have Q multiplied by the price, multiplying the Q all the way through. We get total revenue is 800Q minus 4Q squared plus 0.2A to the 0.5 power multiplied by Q. So we have total revenue, and if we're worried about profit maximization, we have to add in our costs here. And if we add in the cost, this 2Q is the marginal cost of production, and here's the cost of advertising. So what we've done is taken total revenue and subtracted off the cost of production for this firm. So what we want to do here is take the first derivative, one with the respect to Q, and then the first derivative with the respect to A. So we do that first derivative with respect to Q, we get 800 minus 8Q plus 0.2A to the 0.5 power minus 2. And the part that you might find confusing is here is, remember, we're taking the derivative with respect to this, which is equal to 1, and we're multiplying by this. All right, so we have the first derivative with respect to Q. We do the same thing with A. When we do that with A, we can ignore this. Has no A in it. This has no A in it. This has an A in it, so we're going to involve ourselves with this. This doesn't have an A in it, so we don't have to worry about that. And this one we have to worry about. So here, with respect to A, what do? We have to multiply by 0.5. So we have 0.5 multiplied by 0.2, which is equal to 0.1. And then we subtract 1 off of this, which gives us negative 0.5. And we multiply by the Q there, and then the first derivative of A is equal to 1. We can take this and solve it. All right, we set that equal to 0. All right, so this is equal to 0, so we just move this, add 1 to both sides. And if we multiply both sides by A to the positive 0.5 power, this is eliminated. This is equal to 1, so we have 0.1q, and then we multiply this by a to the positive 0.5 power. So we get that 0.1q is equal to a to the 0.5 power. This is important because now we can use this information. We have a to the 0.5 power here. We have it here, so we can plug this in, so we have nothing but q in this particular function. So that's exactly what we do. We just insert this into we substitute that for a to the 0.5 power. So that's all that we've done here. We solve this out. All right, so we have, this is 0.02q when we multiply by 0.2 multiplied by 0.1q. We set that equal to 0 and we move the 2 to the opposite side. And we end up here, so we have 798 equals 8q minus 0.02q. So 798 is equal to 7.98q. We divide both sides by 7.98, and we end up that q is equal to 100. So now that we know what q is equal to, we can just place q, or 100, in place of this q here. So that's all we did, is we inserted 100 in place of q. So we end up that 10 is equal to a to the 0.5 power. And if we square both sides, we get that a is equal to 100. So we got the quantities. The profit maximizing quantity is a. The profit maximizing advertising level, the profit maximizing quantity is equal to 100. The profit maximizing level of advertising is equal to 100. We have our inverse demand function, so we have Q and A, and that will help us determine what price is. So we put 100 in for Q and we put 100 in for A. That's what we have right here. Simplify that a bit. 4 times 100 is equal to 400, and the square root of 100 is equal to 10. So we get P is equal to 800 minus 400 plus 2. Price is equal to 402.